Hey Julia, I'm going to walk you through the second one about, we actually very much overthought this, and it's a lot simpler than I thought. I drew it wrong. So you had said that the vertical velocity was 210 meters per second, and that the horizontal is 360 meters per second. I thought of the 210 as the initial, so for that there, you didn't have to do any kind of calculations and you didn't need the angle. They gave you the vertical here and then they gave you the horizontal here. So you don't have to calculate those like in the golf question. So the question asks you two things. How long is the ball in the air? So we want the time it takes to hit the target, and how far does it travel horizontally from the bomb to the target. So we know acceleration is negative 9.81 meters per second squared. Our displacement is 0 this time, and it's 0 because it hits the ground again. If it was up or down, then we would have a displacement of either positive or negative however many meters. So we have to do two, horizontal and vertical. I'm going to start with the vertical because my horizontal doesn't change. We're given the horizontal displacement, the horizontal velocity of 360 meters per second. Don't need to do any kind of trig calculations to find it. So for vertical, I'm going to do the same thing I did with the golf ball question, and I'm going to figure out how long or what is my time. So my V1 is given to me, it's 210 meters per second, delta T being my time, so I don't know what that is, minus I take gravity, the negative 9.8 meters per second squared, and I put the subtraction sign here. You could still do plus and negative, it's not going to change your answer, depending on if you have to combine formulas, it gets easier on. We're not going to worry about that for now. So minus 9.8 meters per second squared, half of that gives you the 4.9, and we're going to times that by t squared. So now, because our displacement is 0, I'm going to factor. So what I'm going to do is, because I have 1 t in this term, I have 2 t's in this term, I can divide both sides by t. And then this will cross out here, and I'm left with 1 t here, and this t is gone. And I'm also technically dividing this by t, but it doesn't matter because it is 0. So then what happens, I am left with 210 meters per second minus 4.9 t. So now I'm just going to rearrange my algebra, bring this over, so it's negative 210 meters per second divided by negative 4.9 meters per second squared, and that gives me a time of 42.9 seconds, which is the answer key that you have. And what this means is from the time it leaves the can until the time it hits the target, it's 42.9 seconds. Now for the horizontal distance, we're just going to use simple formula, displacement, or the displacement will be the velocity multiplied by the time. So it's 360 meters per second times 42.9 seconds. That gives us a total of 15,444 meters. As per the instructions, you have to change it to kilometers, so you're going to divide by 1,000, which will give you 15.4 kilometers as your total distance. Now, if you were to get a question where you have to find the angle, or you need the angle for some reason, then what you can do is you can do inverse trig. So because you know these two, you can actually go tan, or inverse tan of theta is going to be equal to opposite 210 over adjacent 360. And when you punch that into the calculator, it'll give you theta as an angle of 81.86. So just be careful if you're reading these questions like that. Double check that when you draw them, that we're putting the horizontal and the vertical in the right spot. That is my fault, but good luck tomorrow, my dear. I'll talk to you later. Bye.